All right, coming back to solving equations by graphing. So looking at this is in standard form. So remember, we can find our vertex in standard form by doing negative b over 2a. So we're going to say so our x value is negative b over 2 times a. So what is our b value? Well, remember, if there's none, there's 1, or it can't exist. So in this case, we have negative. That negative stays there, but our number is negative 1 over 2 times our a value is also 1. So the opposite of negative 1 is positive 1, and we have 2. Oh, look, it's your favorite F word again. So we know that our vertex is 1/2 comma something. So if you recall from chapter 2, the way we find this is we substitute 1/2 into here. If you need to turn it into decimals, turn it into decimals. But I think we all know what half of 1 and what half of 6 is. All right, so I'm going to plug in 1/2 into here and solve. So we got 1/2 squared minus 1/2 minus 6 equals 0. All right, can you use the calculator to help you graph? Sure, you sure can, if that makes you happy. Oh, I forgot. No, I didn't. So we get 1/4 minus 1/2 minus 6. So if you don't like this, you can put it in the calculator. Let me go grab one. All right, so you can put it in the calculator. Some of y'all have asked me how to put a fraction in this calculator anyway. And I want you to notice right here, see how that's green? Well, you can get any of the blue ones by pushing the blue button. You can get any of the green things by pushing the green button first. So we're going to just put this in. So I'm going to hit the green button to get my fraction. And I'm putting in 1/4. You can even put in 1/2 squared in this if you don't know that it's equal to 1/4. Actually, let me do it that way just so we can have fun with it. All right. However, you have to use parentheses, or it'll only square the 1 and it won't square the 2. So you have to use parentheses. All right, so we have 1/2. And then we're going to end our parentheses, and we're squaring this. So our square is here. All right, then we're subtracting, need a fraction again, 1/2. And then we subtract 6. And we hit equal. All right, so I know some of you are like, well, Ms. Gill, I have no idea where negative 24/5 or 25/4 is on a graph. Okay, I don't, you could figure it out, say how many times does 4 go into this, blah, blah, blah. But there's a quick button. If you push the math button here, notice how number 1 says fraction. So it turns your answer from whatever it is into a fraction. This will turn it into a decimal. So we want to turn our answer into a decimal. So see how it says answer decimal? We hit enter, voila, we now have a decimal. So if you are a decimal person, we can say that this equals -6 1/4, or -6.25. All right, so let's graph that. Let's count these by halves since we've got this craziness going. So we're going to go over 1/2 and down 246. Not 246, lady. I don't think we'll be able to do it by halves going down. Never mind. Let's just do it by ones. So we're going to do everyone by ones. These are ones. This is -1. All right. So 1/2 then would be in the middle. And we're going to go down 1, 2, 3, 4, 5, 6, and just a tiny bit more. All right, so there's our vertex. This is the point 1/2 comma -6.25. If it makes you feel better to write 1/2 as 0.5, I am okay with that, if that makes you happy. But we need more points. Right? We need to know our x-intercept. So we need to know when y is 0, what is the value of x. So we could pick some points and try them, right? So let's see. If we wanted to graph this, maybe it would go, let's try 2s and 3s. All right, so I'm going to make a table. Let's try some x values. Let's try -2. Let's go this way. Let's try 2 and see what happens just with -2 and 2. All right, what do we get for our y value? So what am I doing here? I am literally just plugging in -2 into this equation. All right, so just going to plug it in. I'm going to zoom out just a little bit. Oh, there we go. Okay, so going to plug in -2 for x. Make sure you use parentheses around the negative or it will not square the negative. It will only square the 2. So minus, remember it is -2. So minus -2. Could you go ahead and put +2? Yes. But to show you that you can literally stick this in the calculator just like that, I just wanted to show you. And we get 0. Oh, so that is an x-intercept. So we know we have the point -2, 0. But Ms. Gill, you already knew that. I did. But remember, I have always told you try numbers on both sides of the vertex. All right. So we don't even... Yeah, never mind. All right. So we're going to now do it for 2. Let's see what happens when we do it for 2. So 2 squared minus 2 minus 6. What do we get? We get -4. So that's another point on the graph. So 2, 1, 2, 3, 4. Now, some of you might be saying, but Ms. Gill, that's usually there's a point the same distance away. You are correct, but remember, we're at the half mark. So let's see, if we go 2.5 this way, what would we land on? So that would be a half, 1, and 2. So let's see what it is when x is 3. Let's see if that's our other x-intercept. So we're going to plug in 3, so 3 squared. Oops, I forgot the minus. Minus 3 minus 6. And we do get the other x-intercept of 0. So remember, your x-intercepts are when your y value is 0. So now we know that there is another point right here. And there is, actually, this is 1.5 away, so there would be another one right here too. So now we can draw our parabola. And if you want to check your work, you could just go into the calculator and you could put it in the calculator. So we could put in, here, let me do it where you can see it. So we could put in x squared minus x minus 6, and let's graph it. And our graph looks like that. It's at the 3 and it's at the 2. So we're doing great. So what are our roots? What are our solutions for this? So we would say the solutions or roots, because remember I told you that's another way to say it. You could say zeros too, are x is equal to, what's our first one? -2. And what's our other x-intercept? +3. Okay? So, let's try this one. So we want the vertex, right? So remember, we need the vertex, we need a -b over 2a, but it has to be equal to 0 in order to do that. So we need to move this 4x to that side. How do we do it? We make it the opposite. So we have -2x squared minus 4x minus 2 equals 0. Could you factor this to figure it out to graph it easy? Sure, you sure could, but this one specifically says by graphing, so I want to show you that way. All right, so we're going to find our vertex. All right, remember we find our vertex by doing -b over 2 times a. So what is our b value? It is -4. So we got -4 over 2 times our a value, which is -2. So -4 gives us positive, and we get a -4. So 4 divided by -4, that's ugly, I will fix it, sorry. So 4 divided by -4 does give us -1. So right now we know our vertex is -1 comma something. How do we find that something? We plug in -1 into our equation. So you can bring out your handy dandy calculator and plug it in if it makes you happy. Could you do it manually? You sure could. But we're allowed to use technology, so why not embrace it? All right, so we got -2. Make sure when you're using this calculator, you use that negative button. And if you're, well, you should be doing the practice in class, but if you're at home, you can always go on Desmos or calculate it the long way. All right, so -2, we're plugging in -1 for x. So instead of x, we're going to say times 1 squared. Then we have minus 4, and we have 1 again, and then minus 2. And what do we get? We get negative 8. Why did we get negative 8? What did I do? I felt like we shouldn't have got negative 8. Hold on, I'll be right back. So silly, I made the biggest mistake ever, or the most common mistake. Okay, so that's why I was like, oh, that just don't sound right. But guess what we do know? We do know that when x is 1, y is negative 8. So we know that point, it's just not the vertex. So 1, 2, 3, 4, 5, 6, 7, 8. So we know if there was a negative 8 down there, we know this is a point. So this is 1 common negative 8. That's what I did. I didn't put the negative in because I was a silly willy. So you have to make that negative. So let's try again, Miss Gill, because you gotta teach correctly. All right. So now we're going to try it with the proper vertex x value, which is negative 1. So times, we got to put the negative in and square it. That is not the right button, lady. Square it. Oh, why is it making it negative? All right, I'm just going to delete those. Delete, delete, delete. Okay, square. Oh my gosh, why are you being so... Okay, I'm just going to clear it out. Okay, there we go. We're starting from scratch. All right, 2 times negative 1. Ah, that's a negative 2, lady. I'll get my life together eventually. All right, so negative 2 times our x, which is negative 1, and we are squaring that. Then we're doing minus 4 times x. Again, lady, your x is negative 1. And then we got minus 2. Now we hit enter, and voila, we have a 0. So our vertex is negative 1, 0. Well, that's also a what? An x-intercept. So are we going to have more than one? Can you plug in another value for x and get the same output? Not if you're making a parabola, you can't. So what do we know? We know our x-intercept is our vertex in this solution. We also know that negative 2 is our y-intercept, so that would help us with a graph. We could have did negative 6 earlier, but we did kind of without writing it. All right. Sorry, the band started and I lost my train of thought. We were doing a point here. So now that we know there's a point on this side of the axis of symmetry, we know there's another one right here. And so same with this. This one's 2 away, so we know there's another one down here that's also 2 away. So now we can draw our graph. And if you want to verify that Miss Gill didn't completely lose her mind in this one, and you want to put it in the calculator to make sure, we could say negative 2 times x, and we're squaring it, minus 4 times x minus 2. And we can hit graph. And Miss Gill did not lose her mind after all. All right, so I'm going to give you one to try. All right, so you're going to pause your video, and I want you to try this one. You can make a little makeshift graph on your paper if you like. So please pause the video, give it a try. We're almost done. All right, so if you set it up to find your x value, right now you would have the vertex 4, comma something. So if you didn't get this far, please pause now, plug in 4 into your equation, and see what you get. Or negative 4. All right, so let's plot that. 1, 2, 3, 4. So we have that point right there. We want to find the x-intercepts. Since we know that there's no... I don't know. I'm sorry. The band is going and it's making me lose my train of thought. I apologize. So let's look. If we're going to draw this, let's try. We can try like 2 and 3. We can try 5 and 6. So let's start with 2 and 3 because those are smaller. Because remember, we can always use our axis of symmetry to find points on the other side. So let's try when x is 2 and when x is 3 and see what we get. So remember, we're plugging them into this equation. So 2 squared minus 8 times 2 plus 12. And that is, oh, look at there, that one is 0. So that is our x-intercept. Let's see what happened if we did 3. So 3 squared minus 8 times 3 plus 12 gives us negative 3. So now we have 2 more points we can put on our graph. So we have 2, 0, and we have 3, negative 3. So because our axis of symmetry is right here, we know that there is another point right here, and that would be our other x-intercept, because if this is our axis of symmetry and that's 2 away, that one's also 2 away. Can you use your calculator to verify it? You sure can. You just need to know what are the x-intercepts. So what are our solutions? So the solutions or roots are x equals 2 and x equals 6. So that is our answers for that one. All right, moving on to your favorite types of problems, word problems. All right, so what do we got going on here? We have a guy kicking a soccer ball. So what is he doing? So let's see. One way to find the maximum or the minimum value of a quadratic function is to first write the function in intercept form. So intercept form is f of x equals a times x minus p times x minus q. So intercept form, factor form, same thing. Because the vertex of a function lies on the axis of symmetry, we can find the axis of symmetry in between those 2 points. So we could say x is equal to p plus q divided by 2, because that would give us the number in the middle of those 2. So the maximum or minimum value occurs at the average of the 2 zeros. All right, so let's dive into this problem. So it says a streaming service company charges $6 per month and has 15 million subscribers. For each $1 increase in price, the company loses 1.5 million subscribers. How much should the company charge to maximize monthly revenue? What is the maximum monthly revenue? So this is one of those questions y'all are always like, Ms. Gill, when am I ever going to use this? For those of you that want to be influencers and you want to make money from TikTok and YouTube, this would help you if you wanted a subscription where somebody pays monthly to like watch your certain videos or interact or however that works. This would be something you could do to figure out what would be the best price to charge. All right, so we're going to let x be the price increase, and we're going to let r of x represent the monthly revenue. All right, so we're going to use x will be our price and r of x will be our monthly revenue. So we're going to write a model. All right, so let's think about this in words since we're dealing with a word problem. So we're going to take our r of x and we're basically going to say our monthly revenue, I'm just going to put REV, our monthly revenue is equal to how many subscribers? So the number of subscribers, I'm just call them subs, times the subscription price, so the sub price. So let's look at it. Well, what's our monthly revenue? Well, that's what we're trying to figure out. What's the best revenue? So what is our number of subscribers? So how many millions of people? So in the problem, we had 15 million, but every time the price increases by $1, we lose 1.5 million. So we can write that. We're going to write millions in just these numbers, but know that this represents millions. All right, so no matter how many dollars we have, we can multiply it by 1.5, we could subtract it, it will give us our answer. All right, so what is the subscription price? Well, right now it says it charges $6 per month. Remember, month is our x. So we're going to multiply this to 6 plus x. All right. So remember, we wanted to try and get it into this format. Yes, I know this is a little extra, but you will be okay. You know they love to throw in these kind of word problems. So just hang in there. All right, so looking at this, I can't really tell what my x-intercept would be. So what I'm going to do is, I know that 15 and 1.5 look very similar. So I'm going to factor out 1.5. All right, I'm going to factor it out. And so then that would give me 1.5 times 10 gives me 15, and that would give me x. However, remember, we can't have a negative x inside, so it's okay as long as you make them the opposite. So x becomes positive, 10 becomes negative. Like I said, we can practice more of these in class if you need to. Bring down the subprice. Now we have it in intercept form. We could actually, let's rewrite it with the x on the left so it's not confusing. So x plus 6. All right, so now we have it in intercept form. All right, so we know our zeros. Our zeros are, remember, they're the opposite, so it would be 10 and negative 6. So to maximize the revenue, each subscription should cost whatever the x value is, because that's going to be the highest point. That's going to be your axis of symmetry. And remember, we're looking at the price, which is your x value. So we want to know the x value of the vertex. So we just need to find the axis of symmetry. So how do we do that? We're going to do this. So if we take our p-value, which is 10, because remember it's the opposite, and we add to it negative 6, then we're going to divide it by 2. So what's 10 plus negative 6? Positive 4. What's 4 divided by 2? 2. So to maximize the revenue, each subscription should cost $6 plus $2 to equal $8. I'm going to flip my paper over and write that down for you. All right, so to maximize the revenue, each subscription should cost the original price plus $2. That would give us $8 per month. So we want to find the monthly maximum revenue. So we want to know what is the y value when we plug in the x value. So we want to find r of x. I'm going to rewrite the equation just so we have it on this page. What was it? R of x equals 1.5 times x minus 10, x plus 6. All right, so we're just substituting in 2. So we're going to plug in 2 and solve. And if you put all of this in the calculator, you would get 96. So what does that mean? That means the company should charge $8 per subscription to maximize the monthly revenue. And how much is that maximum monthly revenue? $96 million. I'll write that down for you. Maximum monthly revenue is $96 million. Please come into class prepared with any questions that you may have, and if you need to practice the factoring or the square roots, there will be a Khan Academy video on this same notebook page that you could practice. All right, until next time. Or see you in class.